Hello, this is Dr. Marion Carroll, Organic Biochem for Nurses at Dillard University. We're going to start Chapter 3, and here we'll be talking about electrolytes. Alright, electrolytes come in two varieties. We have weak and we have strong. So what makes a weak electrolyte? Alright, we define a weak electrolyte as a compound that is usually ionic and that partially dissociates in water. Okay? So partially is the key word. Some examples of weak electrolytes. Acetic acid. Okay, we all know it as vinegar. Vinegar has a chemical formula, C2H3O2. And in its protonated form, it is there's hydrogen on it. So this is ionic because we have two charged components. We have the acetate component and the acid component. All right. And so in solution, acetic acid will dissociate to form the conjugate base plus the weak acid. Okay, and we'll talk about these a little later, but this is in water, so it can remain balanced. And we have 3 hydrogens over here, 3 over here. This this molecule or compound, if you will, is referred to as a hydronium ion, because hydrogen, it doesn't exist in solution simply as hydrogen. It has to complex with water to form H3O, and has a positive charge. So this is a donor of hydrogen. This is an acceptor of hydrogen. So this makes this a base in Bronsted base, and this is a Bronsted acid, weak acid. A couple of other examples: hydrogen fluoride also dissociates to form our fluoride plus our hydronium ion. Water is actually a weak electrolyte. It dissociates. Alright, and one of the characteristics of a weak electrolyte is that they can return back to their original reactant. These are the reactants, and these are the products. And so when we say partially dissociates, and that's what we mean. We mean that it will remain, some reactants will remain when products are made, and some products will be converted back to reactants. All right. What is the other kind of electrolyte? Okay, obviously, strong electrolytes. Okay, strong electrolytes are those that are completely dissociated in water. For instance, sodium chloride. Okay. So completely dissociated in water. Okay, we form sodium ion plus chloride ion. And you'll find that most of the strong electrolytes are part of the group 1A metals. I gave you a periodic table. What do you find in group 1A? You find sodium, you find lithium, you find potassium, cesium. Okay, and these typically form ionic compounds with group 7A. These are the halides: chlorine, bromine, fluorine, iodine. These are the what are referred to as the halogens, group 7A. And so they form these are negatively charged, strong electroconductive solutions, and some of these are found in physiology. Okay, very important in physiology. Of course, sodium and potassium, very important in respiration. Calcium is also an electrolyte that is important in muscle contraction. And other ionic electrolytes in solution: bicarbonate. Okay, let's not forget hydrogen. Okay, and although they're not ionic, they're very important in solution in combination with our hydrogens and our bicarbonates. Okay, so if they are not weak electrolytes or strong electrolytes, if they don't form, if they are not ionic compounds, these only form electrolytic solutions. So if they don't produce ions, they can't act as electrolytes. For instance, C6H212O6, glucose, not an electrolyte. It will go in solution, but you don't produce ions when it goes in solution. Urea, you don't produce ions when it goes into solution. And so this will conclude our discussion on weak and strong electrolytes. Remember these groups where they're found in the periodic tables. Understand what strong and weak electrolytes are all about. And you'll be okay. All right. We'll talk again.